So welcome to application of rational functions. So we're talking about a boat in this case, for example, one, and the boat travels at 3 miles per hour in still water. This is still water, meaning just it doesn't move. It's not like a river. In still water, like a pond or a lake. But in this case, the same boat is going in a river, and it's going to travel at 3 miles per hour. And going upstream, it takes twice as long as it takes to go downstream, so with the current. And it's 60 miles round trip. So they want to know what is the speed of the current. Very first thing I do is I draw a picture. So just a quick picture, nothing fancy, obviously. I just have the water here. This is a river, and the little arrows meaning the current goes from left to right. So upstream means the boat is going from right to left, so it's going to go against the current. And downstream is the boat is going to go with the current. So in looking at what we have here, we have the boat travels 3 miles per hour, and it's going to go 3 miles per hour both ways. The boat is traveling at that speed. Well, when it's going with the current, or upstream, it's going against the current. And so the current is pushing on that boat. So the speed of the boat, what it's able to produce is a 3 mile an hour speed. But you have the current's pushing against it. We don't know, this is what we need to find, the speed of the current. We don't know the speed of it, so it's pushing against, so it's taking that 3 miles an hour, and we got to subtract off the current, how much the current is pushing against, working against the boat. Downstream, so as the boat's going down the stream, the current's actually working with it. And you could think of this like some of you have swam in rivers before, so if you're swimming against the current, it's not, obviously you don't swim very fast because the current's pushing against you. It works the same way the boat. So we have the speed of the boat, and now, but if you're going downstream, it's actually going to work with you. So it's adding the current speed. So keep that in mind when we're doing our problem here. So we've used the 3 miles per hour, and we're talking about as the boat goes up the stream and down the stream. Now another thing we have to talk about is what kind of formula are we going to use? Well, one formula that's pretty easy with this is distance. So to figure out our distance, you have the speed or velocity times time. And so we have our velocity or speed of our boat. We don't have the time, but we can work a little bit with time because we know it takes twice as long to travel upstream as it does downstream. So we can do a little bit with that, but we have also our distance. So the thing I'm going to solve for here is, since we don't know time exactly, I'm going to solve this formula for time. So to do that, we're going to divide by velocity. So we have a general formula of time equals the distance divided by velocity. So if we do on the top picture, we have time is going to equal the distance, 60, both ways it's 60 miles, divided by, here's our speed, or velocity. So 3 minus c. In our downstream, our formula is time equals, again it's 60 miles. Then we're going to, our velocity or speed is 3 plus c. So both of these we have time solved for. So if both equations are equal to time, what we can do is we can set them equal to each other. But we do have to be a little careful with this. We can't just set them equal, because if we set them equal to each other, so if we do that, we'll do 60 over, because they both equal t, so then they have to both equal each other. This would mean that the time is exactly the same for both directions. And we know it's not. If we go back to our problem, it says the boat takes twice as long to travel 60 miles upstream. So here's our upstream. So it takes twice as long, so it has to equal this time here times 2, twice as long. So we have to take the time of the downstream and multiply it by 2. I know it looks weird that we're multiplying by 2 on the downstream side, but to equal the upstream side, we have to multiply this time here, which is right here, by 2. Now, if we solve that problem, we'll be able to solve our problem, or solve this equation. So we have on the left side, it's still just 60 minus 60 over 3 minus c. On the right side, 2 times, it's like 2 over 1, so you multiply the numerators. So it's 120 over 3 plus c. Well, now we have rationals. And when we're doing this, you can either do cross multiplying, or what we've learned already in rationals is if you get your like denominators, you can just drop denominators. So multiply the right side by 3 minus c, multiply the left side by 3 plus c. But there are multiple ways to solve this problem. So when you have like denominators, you can just drop the denominators and then solve your numerators. So we have 60 times 3 plus c equals 120 times 3 minus c. And solving this, we have 180 plus, so I'm distributing the 60 in, 60c equals 360 minus 120c. And keep solving it. So I solved it. C, the current equals 1 mile per hour. 1 miles per hour. So that's the speed of the current. Let's just go back up to the problem to make sure this works. Oh, I got stuff written all over the place. Sorry about that. But here's our problem. 3 minus c, so that'd be a current, so the speed would be 2. And 3 plus c, the speed would be 3 plus 1 is 4. So downstream would go twice as fast as upstream, and that's what it says in the problem. The boat takes twice as long to go upstream as it does downstream. So it works out. So the current is 1 mile per hour. Cool. Moving on to the second problem. So you got practice 1 there. We'll do that in class. Example 2. Just read it quickly. Bill can finish a report in 2 hours, and Maria can finish the same report in 4 hours. How long will it take them to finish the report if they work together? This problem is actually pretty similar to the last one. We have, instead of distance, we have amount of work being done equals rate times time. So whatever rate you're working at times the time is the amount of work you're going to get done. So we have 2 scenarios here. We have Bill, how much work he can do, and we have Maria. So we have Bill. Bill can finish 1 report. So work, that's the number of reports he can do, the amount of work he can do, equals, we don't know the rate at which he's working, but we know the time is 2 hours. Maria, 1 report will take her, we don't know the rate that she works, but we do know that it takes her 4 hours to do 1 report. If we solve for r on both of these, you divide by 2 on the first one. The rate at which Bill works is 1 report every 2 hours, and the rate Maria works is 1 report every 4 hours. That's kind of standard. Probably know that already. So let's keep working on this. If we have, so we want to know if they work together. Together, what kind of math operation is that? You should be thinking plus. To adding, you're putting them together. So we have Bill's rate is 1/2 times, we don't know the time that it's going to take them to work together, plus Maria's rate of 1/4. We don't know the time it's going to take her, but it's going to equal 1 report. We got to figure out how long it takes them to do 1 report. So this is our quick little formula set up, and let's solve it. So we have 1/2 times t, so that's t over 2, plus 1/4 times t is t over 4, equals 1. So we have rational here, we have like denominators. What do you do with like denominators? Or you have denominators that are not alike, get them alike. So move it over here, we get 2t over 4 plus t over 4 equals 1. So we have, we keep in like denominators, we got to divide. So what we have to do, we multiply this side by 4. So you have 4 over 4. So you have all like denominators. So we should have now 2t plus t equals 4. Multiplying 2t, or add 2t plus t is 3t. Divide by 3, you get t equals 4/3. So the time it takes them is 4/3. You can substitute it back into our formula if you'd like, any of the formulas. So you could do a half times t plus 1/4 times t, and you put 3, 4, 4/3 in, you'll be able to tell that it adds up to one report. Okay, that's example 2. So we'll do practice 2 in class talking about Everett. And we'll talk about example 3 also in class. But other than that, just do example 1 and 2 for class. Thank you.